A startling discovery by the James Webb Space Telescope, JWST, has captured the world's attention. Scientists observed what seemed to be city lights in space, an unusual and breathtaking sight. These lights were located 7 trillion miles from Earth, shining from the direction of Proxima Centauri b, an exoplanet orbiting our nearest neighboring star system. The discovery has sparked fresh curiosity about extraterrestrial life. Could these lights be evidence of intelligent civilizations beyond Earth? The JWST focused its powerful infrared sensors on Proxima Centauri b, also known as Proxima b, and detected strange glowing patterns from its surface. To the astonishment of many, the lights resembled urban illumination, the type of brightness we see from cities on Earth when viewed from space. This phenomenon has led researchers to question whether we might be witnessing the footprint of an alien civilization. If these lights are artificial, it could mean there are beings elsewhere in the universe capable of building complex infrastructures. Astronomers have long debated whether signs of life beyond Earth could ever be visible to our telescopes. This moment has renewed those discussions. With technology advancing, we've now reached a point where our instruments, like the JWST, can capture subtle signs of life or advanced activity on other planets. Some scientists believe these lights could be similar to the artificial lighting used in Earth's cities, which remains visible even from orbit. David Kipping, an astrophysicist from Columbia University, commented on how Proxima b's thermal behavior is unlike other rocky planets. Planets usually absorb sunlight and emit it back as infrared radiation. But Proxima b reflects and emits in ways that deviate from this norm. The infrared signature detected by JWST doesn't match the expected profile of a natural object. It hints at something unusual happening on the planet's surface. The JWST's capability to detect minute levels of infrared light has proven crucial in this discovery. Its advanced sensors can capture light emissions from extremely faint and distant sources, even on the night side of planets. This sensitivity makes it uniquely suited to detect the dim glow of artificial lighting, which wouldn't typically be visible in the vacuum of space. Proxima b is tidally locked, meaning one side always faces its star while the other remains in darkness. This could result in one side being scorchingly hot and the other freezing cold. If the lights are from the night side, it suggests that something or someone is producing light to overcome the darkness. The idea of artificial lighting being maintained through long nights leads to speculation about energy sources, perhaps solar panels on the daylight side. This level of technological advancement would require intelligent life, capable of not only surviving but thriving under extreme conditions. The presence of solar arrays absorbing energy on the hot side and distributing power to the cold side is a concept that mirrors advanced energy systems theorized by futurists. JWST's infrared imaging also revealed variations in heat patterns, indicating the planet's atmosphere might contain elements like carbon dioxide, water vapor, or even methane. These gases are considered potential biosignatures. Their presence may imply that the planet could support life as we know it. The presence of an atmosphere can moderate temperature swings, making it easier for complex life to evolve. If Proxima b has these conditions, it strengthens the idea that life could exist or may have existed there in the past. Yet, not all scientists agree on the artificial nature of the lights. Some argue that they may result from geological activity or unique atmospheric phenomena. Volcanic eruptions, for example, can emit infrared light and glowing gases that mimic the appearance of city lights. Another possibility is that magnetic storms or chemical reactions in the upper atmosphere create flashing lights visible to telescopes. To differentiate between artificial and natural sources, scientists plan to observe the light patterns over time. If the lights remain stable or follow a pattern similar to electrical grids, it would point more toward an intelligent origin. Unusual fluctuation or organized intensity shifts could reveal usage cycles, much like power usage patterns in human cities. The JWST's sustained focus on Proxima b over time will help build a clearer picture of whether the phenomenon is random or systematic. Long-term observation is essential. It allows astronomers to identify changes that might indicate the presence of a civilization with regular activity. Understanding the thermal dynamics of the planet helps scientists identify surface features, which could include structures or engineered landscapes. Further complicating the matter is how Proxima B's orbit aligns with JWST's. The telescope has a limited window to observe the planet's full orbital rotation. Fortunately, Proxima B completes an orbit in just 11.2 Earth days, allowing relatively quick full-phase observations from day to night. JWST's unique position in space and its infrared optics give it an unprecedented opportunity to monitor atmospheric changes in real time. But even with these tools, detecting artificial light remains a delicate task. Scientists are cautious not to jump to conclusions. To verify the origin of these lights, future missions must work alongside JWST to cross-check the data from different instruments and perspectives. Ground-based observatories like the Extremely Large Telescope, ELT, are being prepared to take part in this endeavor. The ELT, when operational by 2028, will enable scientists to study Proxima B's atmosphere in more detail, measuring trace gases and reflecting light with incredible precision. Its massive mirror will allow astronomers to block out light from the host star, giving them a clearer view of the planet itself. They plan to use tools such as coronagraphs and star shades, devices designed to obscure a star's brightness, allowing nearby planetary light to become visible. These future instruments could also help distinguish between gases produced by living organisms and those generated through geological processes. Differentiating between life-generated and volcanic gases is one of the biggest challenges in the search for extraterrestrial life. The study of exoplanets has come a long way, and every observation sharpens our understanding of what's possible beyond Earth. While no definitive signal or proof of aliens has been confirmed, the idea of city lights on a distant world invites serious contemplation. For decades, scientists have looked for radio signals from space. Efforts like the SETI Institute, started in 1984 by Jill Tarter and Thomas Pearson, focus on this method. Radio waves can travel vast distances without interference, making them ideal for interstellar communication. However, over 30 years of monitoring have yielded no confirmed alien signals. But the lights observed on Proxima B are now offering a new kind of clue. If intelligent life exists, they may not be using radio technology at all, or they might not be broadcasting in a way we can detect. Instead, visible signs of their presence, like light pollution or atmospheric pollutants, could be the most reliable indicators. JWST is showing us that perhaps the key to finding life is not in listening, but in seeing what's hidden in the darkness. This realization has transformed how scientists approach the search for extraterrestrial life. They're now looking for visual footprints, not just auditory ones. The possibility of technologically advanced life on Proxima B would not only answer the question of whether we are alone, but also force us to rethink our understanding of life's origins and evolution. Would such civilizations be friendly? Are they aware of our existence? Could we one day contact or visit them? These are questions no one can answer yet. But the journey to discovering these answers has truly begun. JWST is also being used to study the atmospheres of other exoplanets, searching for chemical fingerprints that hint at life. Its instruments can identify molecules such as oxygen, ozone, carbon dioxide, and methane, which often appear together in the presence of biological processes. While JWST has its limits, it can only closely examine a few of the nearest exoplanets. It remains our best hope for now. And it's not alone. Other telescopes like the Nancy Grace Roman Space Telescope and international missions are being developed to complement its work. These combined tools may one day help answer the ultimate cosmic question. If intelligent beings on Proxima B truly exist, they might also be looking into the skies, wondering if they're alone, just like us. The universe, vast and ancient, holds endless possibilities. The discovery of these strange lights is just one step into a much larger mystery. Each observation brings us closer to understanding whether humanity is a solitary flame in the dark, or one of many. Our tools are improving, our reach is expanding, and our curiosity burns brighter than ever. We continue watching, listening, and wondering. Because in the vast ocean of stars, anything is possible. Subscribe to our channel and thanks for watching.